Welcome back, chemistry fans. We are going to be doing the conductivity lab today. This lab involves trying to make measurements with a device called the conductivity probe. And what we're going to try and do with that is then understand that the more ions that a molecule has, it's supposedly going to have more ability to conduct electricity. So how we're going to start this is we're going to use 3 different materials. I'm going to flip my camera to the other side to show you what the measurements are that we are going to use. I'm going to use 0.58 grams of NaCl, 1.1 grams of calcium chloride, and 2.71 grams of iron 3 fluoride. Now, the reasons why we chose those particular amounts is because those are 1/10 of a mole amounts. All right, so I'm going to take us down to the surface and we're going to start this activity. So those are my 3 materials that I'm going to use, and I'm going to show myself now making those measurements of those using a weighing boat. So I'm going to start with my salt, my NaCl. I'm going to first push tare so that it's not weighing anything, and you should be able to see that now. And I'm going to put in here 0.58 grams. And I'm going to throw some on the counter too while I'm at it. All right, so there's my 0.58 grams. You can see that now, 0.58. All right, I'm going to put that, just so I know, I'm going to put it in the small container. She should call, because that's what she should do. All right, next, I'm then going to take a second container. And I've got a tare on that one. So now I'm going to use my second material, which is calcium chloride. And I'm going to weigh out 1.1 grams of this material. There it is, 1.1 gram. So I'm going to take that now, and I'm going to put it into my second container. And I have it labeled now, calcium chloride. And then I'm going to get my third amount over here, and that one is going to be the iron chloride. And the iron chloride requires that we get 2.71 grams.
Miss Penny, if you're in the building, please call the main office, extension 5302.
Quite a bit more, because it's a heavier molecule. So it takes more of it to make that same amount. Almost there. Too much. Again, too much. I can't believe that. There it is. Okay, so now I have all of my correct amounts. So I've got all 3 of my containers filled with their materials. And what I'm going to do next is I am going to then fill them with 25 milliliters of water, so that they all have the same amounts of material, same amounts, and they all have the same molarity then, which means that they all are at the same strength. So one is not in an advantage over the others. So I'm filling this up as we speak with some water here. There's 25 milliliters. I'm going to do the same thing for the next one. I'm going to put 25 milliliters into the calcium chloride. Because how strong the solution is might make a difference in its conductivity, because if it doesn't have a whole lot per container, then it's going to not do as well with the conductivity as it would if it were with lesser amounts of water. It would do conducting electricity a little bit better. All right. So now what I'm going to do is I'm going to start stirring these up to dissolve them up nicely so that there is no extra solids in here. And hopefully you can see that now is the case with that first one. I will do the second one. And it looks like it's pretty well dissolved already, but a few more stirs there, and that one has now dissolved completely. And the same is going to be the case with my salt down here. I'm going to stir it up nicely, and it looks like, look, it's all dissolved. Okay, so now my final step in this process is that we're just going to take this and take these pieces of data and connect them to what is called a conductivity probe. So I've got right here a veneer conductivity probe. It is already connected. Now, if I were to take this and put it into water, which it is right now, it's being held in water, you can see it doesn't have a whole lot of conductivity in it. And that's what we would come to expect because water doesn't have a whole lot of electrolytes in it. But what if we started to put it into these containers here? So let's see what happens when we put it into salt. So we've got a value here that I'm going to write down. Okay, I'm going to try and pretend like I didn't just spill all of that. And we're going to say 29,150. 29,150. That looks pretty good. 29,150. 29,150. I'm going to write that down. 29,150. For NaCl. All right. Now I'm going to do the second one. And I won't make the same mistake this time. I've already rinsed it off. So I'm going to put this on here and notice what its conductivity is. 36,450. 36,450, we'll say. 36,450. 36,450. 36,450. 36,450 for the CaCl2. And then the final one. So it's gone back down. Let's put it into the final one. And let's see where our conductivity is. 52, it looks, where is it? 52.8. 52.9. 52.950. 52.950. Okay, 52.950. And that's for the FeCl3. Okay. So now I've got my data. I'm going to switch my camera back here, and we're going to go over and we're going to create our own data points on this one. So now I am going to come over to Google, and I am going to, oops, I need to share my screen with you. Share my screen with you. And what we're going to do on Google is we're going to look for Google Sheets. Sorry. Google Sheets. Hi-oh. I can pause this here. I'll resume share. And okay, so I've got my three values. So what I'm going to do is put these in here on Google Sheets. So I've got NaCl, I have CaCl2, and I have FeCl3. And I have my values of 29,150. I have 36,450, and then I had 52,950. All right. So these are my three values. I'm going to come over now, and I'm just going to allow it to insert a chart, and it should make well, it made a pie chart, but I want it to be a bar graph. All right. And notice what happened. It's exactly what we hoped for. We are seeing an increase in conductivity with the number of ions. This is everything that I wanted to share with you. Thank you so much. We'll talk again soon. Bye-bye.